Okay, good morning, afternoon, or evening, everybody. Welcome to the Keeping Pace Introduction to Pace Mission Products and Data Data Discovery Earthdata webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight saving time. So we're going to go ahead and get started. And what I'll do first is begin today's webinar with just a few logistics. To ensure the best audio experience, all participants have been placed in silent mode. But if you have any issues or you have questions, what I'd like for you to do is enter those into the Q&A panel rather than the chat. And you should see that located on the right side of your screen. Today's webinar is being recorded. The recording will be posted both to the NASA Earthdata website as well as to our NASA Earthdata YouTube channel within a few days of completion. And then once post-production is complete, what I will do is I will send an email to all of the webinar registrants that will include the recording link and also a link to this afternoon's presentation slide deck. Okay, as far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and live demonstrations. After that, we'll have a 15-minute, excuse me, Q&A period, and depending on the volume of questions that we receive during the initial Q&A, we may extend the Q&A session an additional 15 minutes from end time, but we will have a hard cutoff of 3:15 p.m. Okay, during this afternoon's event, we have one speaker and we also have one question and answer panelist. Our speaker this afternoon is Alicia Scott. Alicia is the Deputy Manager at NASA's Ocean Biology Distributed Active Archive Center, or OB.DAAC, and that is located at NASA's Goddard Space Flight Center here in Maryland. She will begin today's webinar with an introduction to the PACE mission and its expected data sets. And then from there, actually, let me go ahead and switch over to the agenda so you can see. And after that, what she'll do is transition to PACE data discovery and data access demonstrations and associated content. After this, we'll talk about how to access PACE data in the cloud, and finally wrap up this afternoon's event with information about and links to PACE data learning resources and tutorials and opportunities. After our speaker is finished with her presentation and live demonstration, what we'll do then is we'll transition to a final optional set of polling questions, and the question and answer period will open at that time. During today's question and answer period, our panelist will be Sean Bailey. Sean is the manager of NASA's Ocean Biology DAAC, or OB.DAAC. And just a quick final note about the question and answer session. We will try to answer all of the questions within the time allotted, but if we're not able to address your question, our speakers will be able to follow up with you offline. With that, I am going to stop sharing my screen and introduce this afternoon's speaker, Alicia Scott. Alicia? Let me stop sharing my screen.
Hi, everyone, and I will start sharing my screen.
You should have presenter privileges now.
Thank you.
You're welcome.
Okay, how does that look, everyone?
That looks good to me.
All
Thank you.
Thank you very much. Last thing I wanted to do, just so that I don't interrupt. Okay. Hi, everyone. Thank you for attending today's talk on NASA's groundbreaking PACE mission. We will talk today about the data products and discovering data at OB.DAAC. And we did just go through the agenda, but just to recap, the first thing is an introduction, then we'll talk about the data products, finding PACE data, how users can prepare, and we'll look at some resources on training and tutorials that are available. So I wanted to start by giving an overview of the organization of NASA's Distributed Active Archive Centers, or DAACs. There are currently 12 DAACs across the United States, each with a specific discipline, as noted by the name: land processes, socioeconomic data, crustal dynamics. And we are in Maryland, as mentioned, at NASA's Goddard Space Flight Center, and we represent the Ocean Biology DAC. OB.DAAC became a member of the NASA DACs in 2013, and we are co-located with our data provider, the Ocean Biology Processing Group. That is just significant because while OB.DAAC archives and distributes the spacecraft data, it's OBPG who is responsible for the processing of the data up through the higher levels to level 2 and 3 with temporal and spatial characteristics and binning and mapped products. OB.DAAC will be the primary data archive for PACE data. The PACE mission, which stands for Plankton, Aerosol, Cloud, and Ocean Ecosystem, has advanced technology aboard that will enable it to not only extend the records of NASA's heritage missions, but also allowing it to see beyond what prior missions have been able to unveil. Uh, more information, just background for PACE. We celebrated a pretty flawless launch on February 8th, 2024, and where it reached its cruising altitude of 676.5 kilometers above the Earth. And the spacecraft will remain at this altitude in a polar, ascending, sun-synchronous orbit, crossing the equator at 1300 UTC or 9 a.m. for Eastern Daylight Savings Time. The mission has 3 instruments, so they will be managed jointly by NASA Goddard Space Flight Center for the OCI instrument, UMBC for HARP-2, and SRON, Airbus Defense in Space, for the SPEX-1 instrument. We'll expect to receive our first data in April 2024, so very soon. And over the span of the mission, we expect to amass a total of about 1.5 petabytes in our data archive here at OB.DAAC. Oh, I should mention on this slide, we do not expect all the data at once. So we'll do a phased release of data, and we can talk more about that on some upcoming slides. The instruments, as I mentioned, there are 3. So the first instrument, the primary instrument, is OCI, and that is an advanced global imaging radiometer with a continuous range of ultraviolet to near infrared. SPEX-1 is a narrow swath multi-angle polarimeter, which is also hyperspectral and has a range of ultraviolet to near infrared. HARP-2 is a wide swath hyper angular polarimeter with visible to near infrared spectrum. So with all 3 of those instruments, we gain hyperspectral capabilities that will be the key to extending climate data records, enabling the identification of phytoplankton species, which will reveal the diversity and distribution of organisms across the world oceans. This will also shed light onto how those species respond to environmental change. Having the ability to combine data records from the ocean, cloud, and atmosphere allows PACE to highlight the change across the entire globe. Bringing out some of the advancements that we'll get from all 3 instruments. This slide is showing how on the left side, we can see the heritage missions, CZCS, CWIFs, MODIS, and VIIRS, and how we could see them improve over time by offering more of the wavelengths along the visible spectrum. So we can see that improvement over time. However, PACE drastically increases the available wavelengths that we will be able to see into. And over on the right, we have the same information in the form of a plot. And so from VIIRS, we can see the wavelengths that are available, and we can see how when we get data from PACE, from OCI specifically, that will get a lot more of those data points filled in to be able to tell a more complete story. On the slide for HARP2, what we're seeing is actually from the HARP CubeSat, and this is an animation provided by UMBC. It's showing the CubeSat cycling through different angle views of a Saharan dust plume off of the coast of West Africa. HARP2 is based on the same technology and will provide the same multi-angle capability for the PACE mission. On this slide, for SPECS 1, we see that there are 5 different viewing angles of the polarimeter. And what happens with those wavelengths is that they'll go through the telescope, through the polarization modulation optics, and there are 2 different polarization directions denoted here by horizontal lines and vertical lines. Once they go through the spectrometer, those different viewing angles and the different spectrum views will be stored at the detector. I think that is what the entire image is saying. Hopefully I didn't ruin that too much, but that is significant because we're getting a much wider amount of information from the one instrument. Some information about our data products. These first couple of slides are just here to highlight the importance of the atmospheric contribution and oceanic contribution of all of the different data products that are available in general as data points. So a point that we added here is that water leaving radiance comprises 5 to 15% of the total atmospheric radiant signal. And so combining what we get from the ocean and atmosphere is essential. If we zoom into atmospheric products, we're just going to list some of the different data points that exist there. And then in the ocean, we have the same thing. All of these data points are available. And traditionally, we would have one mission capturing the atmospheric or the ocean color separately. But for PACE, we're able to get all of the data points from one mission and combine them together. So this page is just a little bit of a list of some of the data products that we'll get back from PACE in the different disciplines of land, atmosphere, and ocean. There are many more products, including combined products across these disciplines that are available. And the instrument products will be listed on the Ocean Sciences website. And this page in particular also tells when they will be available after the spacecraft begins releasing data.
Okay.
So we will go into looking at actually, before we go into the finding data products, I think I wanted to just give a little bit more detail on the data products that we will have available. Just as things to look forward to for PACE. So we mentioned on some slides back that data release will be expected April 4th, which is next Thursday. And in that first batch of data, users will get hyperspectral radiances from OCI and our Heritage Ocean Color products up through level 3 from our polarimeters HARP2 and SPECS 1. we should get multi-angle radiances through level 1C. So at the time of data release, a press release will also come out, and that will include first light imagery. Any products after that first batch will be announced and released after reviews by the principal investigators. Okay. So now we are looking into how do we get data for PACE and for OB.DAAC in general. The main tool that users should use to access data is Earthdata Search Client. And so that does have data from all of the DACs that we talked about earlier. And if that is a lot of information in one space, you can take advantage of the data portals, which narrows it down sometimes by project or by the DAC. And then you'll just have less data sets to filter through. Another data access option is called Earth Access, and that is a community developed Python API that allows users to download data via the script. And third option is from the Ocean Color website. On our website, we have a navbar link, which takes you to our data access areas. And the three that we want to focus on are direct data access, our file search tool, and the level 3 and 4 browser. So I wanted to stop there to go over to a browser and let you guys see those tools. Let's see if I can get that to go away. I have an extra bar that's blocking my screen a little bit, so I'm going to pull this down. Okay, so this one is Earthdata Search Client. There's an option to log into it. You don't need to in most cases, but what gets used as the login is your Earthdata login credentials here. The top nav bar does have a drop down that shows all of the DACs that have data here in the tool. You really don't need to go to any of these links unless you want to learn more about that specific DAC. So what we see on the screen on the left, you can find data by using all of these filters that are available. And all of these are drop down, so you can choose whatever parameters are relevant to your search. And there are a few quick buttons, items that are just in the cloud, items that are customizable, or has map imagery available. You can even see collections that don't have granules yet. Underneath, this is a free search option box up here. So if all you know is that you want paste data, then you could type paste there and see what gets returned to you. Now there's 3 boxes underneath that I didn't talk about, and those are just for temporal and spatial parameters. If you wanted to narrow by those and by specific feature, looks like it's got regions in there. So there are a lot of options available in Earthdata Search. Additionally, if you prefer to not use any of the items on the left, you can use the map. So if I close this area that showed what data were available, you can choose any of these polygons or other options that are along this right side on the bottom and get back data based on a region. And you can see the values will fill in over on the left for you. And I narrowed our search down from about 9,000 collections to 12 by using the map. Another thing to note is when you see the collections here, you get back a clever icon if it is available in the cloud. You should see that there. I'm going to clear my search because I also want to bring up more options that you'll see in this section here. So this first collection, we can see ways that you're able to customize this collection. So spatial, temporal, variable, and reformatting are available with this data set. And so I will give you more information on the collection, and adding the plus puts it into your cart. I'm going to click into the collection because I want to see what granules are available. And I just chose one that was in the list. So I will use the filter and look for data between October 26th, just based on what the first granule there says, through October. Oh, looks like my screen is sort of cut off there. So I'll type in the 27th. And then I get at the bottom, it gives me an option to download the 208 granules that match my search. So if I click that, wait for the collection and the granules to populate on the left. So it looks like it's done. And if I click onto that, then you can see each one in a list. If just in case you may want to, delete a couple of them out of there, you can do that. And then it also displays on the map if you click. So if I press download from here, it goes to this next screen. And it's taking a little bit to populate for me. But the collection that I chose was a collection that was available in the cloud, and I did that on purpose because I wanted you to see that there are 4 different ways to get the data back. So you can either just download the files by copying each of these data access links and downloading to your machine. S3 Access gives you the same thing, except for it's linking you to an S3 bucket on AWS. There are also links when a data set is available in the cloud to using your credentials in AWS and showing you what region the data are in. Using a script, you would click this tab, and viewing the browse imagery, you would click here. So you would decide at this point what you wanted to do and get your data. So that is Earthdata Search Client. And I just went to the page that describes Earth Access a little bit more. It's also linked on the slides, so you guys will have it. And this was the part that I pulled out for you, so you can see what it does there and get more information from that site. On the Ocean Color website, I'm just going to go exactly like I had on the slides to our direct data access area, and you get a table back. And these are also tabs in case you wanted to filter data down in any way. And then you would just click into a level and a data product and get the data back from our direct data access area. So if I click all the way in, there are the data files, and clicking them from here, download them to your computer. On this screen, we have file search, and we have, we would choose the instrument, and they're listed here by platform instrument in that first box. If you want to narrow down the level, or we're calling it our data class, you would use the buttons here or show everything. Same here, you can choose to narrow down with refined data or quick look data or everything that's available, and you give it a time range to find your data. There are a couple of additional options which will give you back a text file, or if you don't click anything, you'll get a page on the next screen that just shows them also sort of in a table where you can click into and download each file. On the bottom, What's really convenient about the file search tool is that if you prefer to get them from command line, as you're filling in options up here, it combines those options into a wget or curl statement. So you just need to copy those. And you can just take those over to the command line if you prefer. But if I do a submit query, I should get a new page. Oh, and I didn't log in. So I'll leave everything as it is just to show the next page. I probably should have chose less data, but it's thinking. While it's thinking, there we go. Okay, so that's the option if you choose getting the data files back. I'm going to stop that. And so I'll move on to the next product. Let's reduce this time frame to just yesterday and submit that query. Oh, I missed a step. I didn't choose my data type. So click those. And that's what the next page looks like if you just have the data returned over the web. The bottom will have page numbers if there's several pages of data. On the level 3 and 4 browser, also in quick links on the Ocean Color web, we have the same sort of interface where you would choose the parameters that you want to search on and your data product. And you can either click into it to download the data file, mapped, binned, or the image file that you see here. Or if you choose your parameters and click extract or download, then you go to the next page and you get a few more options. You can either download them directly or you can do some extraction, so selecting an area on the map. And if you want to preview your region, it should give you a map. There it is. And then this will allow you to submit an extracted data order. So those are our data tools. Well, goes back to that by default, I guess. Okay, so back to the presentation. How to prepare for PACE data. There are a lot of options for cloud services, but NASA had to choose one. So we decided to go with Amazon Web Services as their cloud data provider at NASA. And so all of NASA data will be available in Earthdata Cloud with Amazon Web Services as the data provider. Our data will be in the region US West 2. One thing that users are probably aware of is that we have to use Earthdata login as a way to authenticate who we are in order to download any NASA data. The same is true for using data in the cloud. So make sure that you create an Earthdata login account in order to access data and work in the cloud. We recommend that you create an account also for AWS in the US West 2 region and NASA developed resources. One that's really a great resource is the Earthdata Cloud Cookbook. That was developed by a community of DAAC participants working with the OpenScapes community. And what they did was do several workshops for cloud operations and working with data in the cloud, and combine all of them into what they're calling a cookbook. So it's available online. It's got tutorials, examples of workflows, and I guess what they're calling like a cheat sheet for working in the cloud. Benefits, in case people are wondering, when is it a good idea to work in the cloud? There is improved performance over working with data that's available on premise, just because processing speeds, if you're working in the cloud, should be a lot faster, particularly if you're working within the same region as the data. It provides another data access method. So depending on what kind of work that you're doing with data, if working in the cloud is optimal for you, then now that's an available option, and you're not limited to only the resources that were available before. Multidisciplinary data access, that just means that, as I said, all of the other NASA DACs are also moving data to the cloud. So you'll have access to not only ocean biology data, but all of the other DACs that we had that had the other discipline areas are available in the cloud too. So if there were any kinds of research that you were interested in doing across disciplines, you will have access to those data as well. Analysis next to the data, we're getting resources together, and some actually already exist in the cloud where the data are not only available, but you can also do some processing in the cloud. So the benefit of creating your account in US West 2 is that your processing will be in the same place as the data, which again will improve performance. And another benefit is expanded services, meaning that whatever the Earthdata Cloud provides as additional resources, you would have access to all of those as soon as they're developed and available. Some trainings and tutorials that we wanted to make sure you were aware of. Learning about the cloud is something that we really want to stress as an important step for users. So here's another page that's available on the Earthdata website, which provides a primer on Amazon Web Services and using the cloud. On that site, there's everything from why you should use the cloud to understanding managing costs in AWS, bringing your scripts into the cloud, and other topics. On the Ocean Color website, this is a resource related to using your data once you download it to your machine. So we have some Jupyter notebooks that we started developing, and these are also things that you'll be able to do with PACE data, because again, PACE will include the heritage ocean color data products. So these notebooks, read and plot level 2 chlorophyll map, download and visualize level 2 products, read and plot level 3 files, and these are resources that we're going to continue to develop and make available. So look for more topics to come. There are a set of lectures that were put out on YouTube from, I should have written this out. It's they're NASA lectures. I'll say that so I don't ruin what OCB stands for. And so there are a lot of lectures there about just how spacecraft download data to the ground and how we get at that data and process it. to PACE-specific lectures if you want to learn more about the mission itself. So there's a lot of great lectures in there. There's also a bit of information about the PACE applications. So I'm not sure if anyone on the call today has ever been to a PACE applications web workshop, but some information from those is also listed in those lecture series. We have upcoming opportunities for PACE data users to work closely with the data. And so we're calling that PACE Hack Week. That's an event that's happening from August 4th through 8th. The window for that has closed, and that's a workshop that is in the process of being planned out. All the participants already have have signed up, and we wanted you guys to know about it because there will be presentations and code that will make publicly available once the session is completed. And available means they'll be available on the Ocean Color website, possibly on the OpenScape's website. You'll find them on all of the resources that we have. And we also have a mailing list, the Ocean Color mailing list. If you want to be informed in the future about opportunities, announcements, and any data related messaging, that is a good mailing list to join. Analysis and visualization support are provided by our software called CDAS. And we have a new release for CDAS coming also the beginning of April 2024 in support of PACE. So some of the improvements to the PACE software, the CDAS software, will be support for multi-angle polarimetry data, and there will be a data animation feature added. This is a slide just to show a level 1C HARP2 data set that is going to be animated in angular view. And, oh, wrong button. And so this is the window that shows up where angular view was chosen on the last slide. So this one is showing the spectrum view. And then these different bands can be excluded or included at the user's preference. But spectrum view was chosen here. And so I'll play that one as well. So those are really exciting features that I know the CDAS team is excited to share with the users, and I hope you guys find them helpful and that they allow you to do your research with PACE data. And to find more tutorials about just learning about PACE or the features that are available in PACE and examples of case studies, the website is listed there where you can go to find out more and learn about PACE. I keep saying PACE, I mean CDAS. Hopefully you guys are at least reading the screen and you catch where I'm messing up here, but CDAS material are available there. So that is all I have for today for you guys. The last couple of slides are just reminders for ways to stay in touch with us and pointing out the learning materials that we have available. So the Ocean Colored mailing list that I talked about, here's just the link to where you would email to subscribe. And then the learning for the cloud, very important. There's the cloud primer link, and our user support resource is called the Earthdata Forum. You'll also log into that with your Earthdata login credentials, and then you can ask questions to the user community as well as the DAAC subject matter experts everything from data access to mission questions that you have, we'll answer there. And then here are 2 links so that you guys can learn more about PACE data and its products. So the first link is to the PACE main website, science website. And the data page that I showed that had the different data sets that are available across ocean, land, atmosphere. The second link will take you there. You can look closer at those different data sets that'll be available. Thank you, everyone.
Okay, thank you very much, Alicia. So I will actually try to put a link to the OB.DAAC mailing list landing page, although again, it is within the presentation slide deck. I'm going to paste that now. At this point, what we'll do is we will open the final optional polls and we'll transition to the Q&A. So we have quite a few questions in the chat, and then also we have some questions in the Q&A, but I'll start with the chat first and then transition down to the Q&A panel. So give me one moment to open up the polls and we'll get started here. All right. So we are going to go ahead and get this opened. You should be able to see this in just a moment. Okay. All right. Thanks, everybody. I'm going to hop to the chat and kind of, it's a little bit more challenging to keep track of these. I'm going to have to scroll a little bit here. So if you could bear with me. Thank you. I'm going to start from the top. And then Sean Bailey. So we've got Sean Bailey on deck as a Q&A panelist. Again, he is the manager at NASA's Ocean Biology DAAC, and of course our speaker, Alicia Scott. So our first question that I see here, can we extract the algal bloom biomass concentration for global scale, for example, temporal and spatial? I did not see any data in a NASA Ocean Color PACE data access website.
Yes. So PACE data access, we don't have any data available yet. April 4th is the expected data release date. So this presentation is a little bit early, but if you guys follow ways to be prepared for the PACE data, which it will be available in the cloud, then it will be available on all of those data access pages that we showed, and you'll be able to work with it from there.
Okay, and just as a follow-up, I am recording this afternoon's event, and it is my intention to include additional links when I send a follow-up thank you message to all registrants. So if you have a colleague who was unable to make it today, who was perhaps registered, not to worry, I will send those links out to everybody, and this way you'll be able to follow along in terms of the data access and data discovery tutorials and demos that were provided today. All right, so let's see. I think there was an answer to this already with respect to whether or not the data would be available at the Giovanni Visualization portal. And Dr. James Acker from our Goddard Data Center, also at Goddard Space Flight Center, noted that we have not discussed PACE data and Giovanni with OB.DAAC yet. You know, the tool itself might be undergoing we are expanding some of our tools to include additional data sets and serve as enterprise-wide tools. So there may be some changes there, but if you have general questions, feel free to please ask those questions either in the Q&A panel or the chat. So the next question, let's see here. Are there any plans to develop APIs in other languages other than Python? And I believe that this question came in during the time period when you were discussing Earth Access Python library. So if either Sean or Alicia could respond to that one, will there be plans to develop any other APIs in languages other than Python for accessing PACE data?
Well, we do not have any plans to, but if there's a sufficient desire from the community to do so, we can explore it and add it to our list of things to do.
Well, thank you so much, Sean. All right, let's see here. I'm just scrolling down the chat. Thanks for being patient.
Jennifer,
Okay,
while you're
go ahead.
scrolling, I think I recall that that could be one of the polling questions. So please also pay attention to the polling questions in terms of what types of languages are you using, I think is
Yes,
like what it's worded like. So
that's correct.
please fill that out and we'll make sure to take that feedback.
Wonderful. Thank you so much. Let's see here. Just making sure I haven't missed any. I will continue to post the presentation slide deck in the chat. Let's see. Okay, the next question is, when will CDAS version 9 be available?
We are planning for April 1st. So um, the the goal, of course, is to have it available and publicly released by the time the data is publicly released. So that's the
Okay.
goal.
Okay, perfect. There was an additional question here. I think, I'll fix the link. When pasting the hyperlink for the OCB trainings into the chat, it was not linking the last segment, but I will fix that in a moment for Alicia or Alicia, who entered that comment. Thank you so much, and I will enter that into the chat in just a moment. Okay, so the next comment, but it's worth addressing here, there's also a question at the end, is it sounds like one has to have a cloud account in order to use PACE data, or can one download the data and analyze it offline?
You do not need a cloud account, and access to the data will always be available the way it has always been with all of our data from the OB.DAAC. So moving to the cloud just means that where we're storing the data, and if you happen to have access to a cloud account, you can have direct access to the S3 bucket, and it would be, you wouldn't have to download the data to manipulate it and make use of it. However, if you're more comfortable continuing finding the data and then bringing it down to your own machine, that option is always and will always be available.
Okay, thank you, Sean. So the next question is, and I really only provided a very generic answer because obviously Terra is in, kind of the decommissioning phase F, I believe. And so the question is, how long will the MODIS data be continued to allow those, or to allow those who'd like to transition to PACE to do so? So I do not have a definitive date for that, at least for the Terra data that, based on what we know today, Terra would be the first to decommission. So do you have
Actually,
any
it's the other way
updates for
around.
that? Is it really?
Yes.
Oh, wow. Okay.
But both of them, both Terra and Aqua, are going to be decommissioned by early 2027. So
Okay.
I believe February 2027.
Oh, interesting. Okay, well, perfect. So that at least provides a little bit more, definitive time frame to the question that was posed earlier. So thank you for that. Okay, the next question is, can PACE data be used for nighttime aerosol monitoring?
No. PACE is, the instruments are only operating during a daylight side. So calibration maneuvers are done on the dark side, but we do not collect any data at night.
Okay, well, thank you, Sean. The next question is, how does the hyperangular rainbow polarimeter or the HARP2 different angles will help us understand dust and other aerosols, like the example given in the presentation about Saharan dust plumes?
That's a great question. I wish one of our atmosphere folks was here. Having views from different angles allows us to identify things that we currently aren't capable of doing from a single view, such as the height of the aerosol, which is extremely important in determining aspects of it. So it's great, and there are some really cool things that they can do. I know one of the reason that HARP is called has the rainbow polarimeters, because they actually can look for the cloud bow effect, which is actually very similar to the rainbow. They can be able to distinguish between ice and liquid water cloud droplets. So yeah, the hyperangular stuff is pretty cool, but I can only say it from a layman's perspective because I'm an oceanographer.
Thank you, Sean. And I think certainly we can follow up offline with this particular webinar participant on that question. Let's see. So I'm going to hop back up to the chat here and go ahead and ask this next question, and then transition back down to the Q&A panel. Okay, so the next question is there any chance to have the ocean color data sets in the Google Earth engine?
That is pretty much up to Google. They have pulled some of our other products into that, and I'm sure that when they see the popularity of the PACE data, they'll equally do so. But we are not actively seeking to put it there, but they are probably going. I can imagine that they will, but I can't say for sure.
Okay, well, I appreciate that response. The next question is, okay, where can we find out more information about PACE, OCI Level 1B data, and instrument characteristics?
I put the link in the chat to the PACE website, and if you click missions from the nav bar there, you'll see each instrument listed, and there's an area on the right of the page, I believe, that shows more of those details.
Okay, thank you, Alicia. The next question is, are we to assume that the data will be included in CDAS 9 once released that is independent of having an Amazon cloud instance?
Yes.
Okay, perfect. Okay, so the next question is, perhaps we can address the, it's something that could be an entire webinar, the topic all unto itself. But the question is, how will the data gathered by NASA's PACE mission contribute to enhancing our understanding of ocean sustainability? And what role can young individuals play in advocating for and implementing sustainable practices to protect our marine environments? So perhaps we could tackle the first part of this question. And if you have any input on the second part, so again, first part is, how will the data gathered by NASA's PACE mission contribute to enhancing our understanding of ocean sustainability? And what role can young individuals, is the second part, play in advocating for and implementing sustainable practices to protect our marine environments?
You weren't kidding. That's a semester college course. So PACE the ocean color imager providing us hyperspectral data allows for us to look at more than we were able to detect from our multispectral heritage missions. What we're hoping to be able to derive from PACE would be things like community composition structure. So we'll be able to distinguish what types of phytoplankton are present in the water, as opposed to just the biomass volume that we get from an estimate of the chlorophyll concentration. So being able to distinguish the types will let us know how the oceans are changing over time. So we can see that change more subtly in the hyperspectral signal that we can, and the multispectral signal that we're getting. How that would translate into sustainability is a completely different question. So it's not really sure I can give an adequate one now, so I won't.
And I do think there are some ideas online within some of the NASA projects that are really focusing on applications. And so I would be happy to follow up with links to some of those projects and ideas for you to explore further. For that webinar participant, we really appreciate you, you know, putting the thoughtful question in the chat to begin with. So thank you. So I'll follow up with you separately offline with some additional information to explore. All right, so the next question is, for the slide on PACE data products, Ocean Color, one of the products shown in the graphic, is bathymetry classifications. Can you speak to what that product will provide specifically?
Maybe I missed that because PACE isn't giving us bathymetry. The bathymetry is a static data set that we have that we're able to use to select data within CDAS. So does that make sense? We're not actually looking, we can't detect bathymetry with PACE. So.
Okay, thank you, Sean. All right, let's see what we've got here next here. I did provide a link, a detailed data set like the data products table that was provided earlier on in the presentation. There are links to data set documentation and certainly a more in-depth explanation for each of the products. And I will also include that when I follow up offline with all of the registrants. Is phytoplankton biomass concentration available for algal bloom data in spatial and temporal for global through PACE?
Yes, I mean that is the heritage product, the chlorophyll concentration product that we get from our heritage missions will also be provided by PACE OCI.
Okay, thank you, Sean. The next question is, will we be able to create subscriptions for PACE data on April 4th?
Maybe. You will be eventually. I cannot guarantee right now that April 4th we'll be able to initiate a subscription, but because
Yes.
there's a lot to it, but our hope is that yes.
Okay, thank you. So the next question, I'm hopping back up to the chat really quickly, and then we'll skip back down to the Q&A. I just, as they come in, it's easier for me rather than scrolling through the entire session. So the next question is there an update on post-launch OCI performance? The previous webinar on this topic was by Gerhard in 2016, or Gerhard, I'm not sure. I hope that I am pronouncing this individual's name correctly. So again, is there any update on post-launch OCI performance?
It's awesome. Yeah, we have been looking at it as we've been spending pretty much the last 2 months since the instrument's gone into orbit. We've been collecting data and looking at the characterization and how the pre-launch calibration characterization is performing, and it's actually performing very well. It's not perfect yet, but given a little bit more time, we will obviously make some more updates and corrections, but it's phenomenal right now out of the box. The engineers did a fantastic job putting this instrument together.
Okay, well, that's exciting news. We can't wait to see the data. Okay, so the next question here is, let's see here. And I may have asked this question earlier, but let's see. Does PACE have algal bloom concentration data in terms of phytoplankton biomass?
Yes, that was the question we already answered.
Okay, gotcha. All right, let's see here. I'm just scrolling to see if I have missed any questions in the Q&A panel. Yes, you're correct. I think it was asked 2 different times by same user. My apologies for that repetition. Let's see. There was just a comment earlier that said the formats on the different data, raw and processed, is essential. If you had any additional comments for that particular webinar participant, please feel free that you'd like for us to share with our speaker and panelists, please do feel free to note that in the Q&A or the chat. That would be fine. I don't think I have missed any questions. I'm going to take another look at the chat. All right, so I don't think I've missed any questions. So just as what we'll do now is just go over a few things really quickly. What I will do, if there are no further questions, I will leave the virtual meeting space open an additional 15 minutes or so. So if you think of any questions, also we want to have enough time for feedback for the optional polling questions. So if you think of something that you would like to have shared with with Alicia or Sean, or something that needs to get, maybe a question for the science team, I will send that information along. Feel free to add that to the chat or the Q&A. And our speaker and Q&A panelist will be able to follow up with you offline. Today's event is being recorded. It will be, it takes me a couple of days for post-production. And so I aim to have it posted by Friday, although it is possible that it will not be available until Monday. Because I get this following question quite frequently, we currently do not offer certificates of participation for our webinar series. However, we are looking into, offering a certificate of participation for our NASA Earth Data webinar series. It is just not something that has been implemented yet. So I thought I would add that now, although nobody has asked about it in the, okay, nobody has asked about it within the webinar. So just as a follow-up, since we're not out of our extended time yet, the bathymetry classification that the participant was referring to was shown on slide 16 of the slide deck, just for reference for everybody. So let me put the slide deck in here again, and Sean, if you want to take a look, perhaps that you could then, let's see. All right. I'm going to put the presentation slide deck link in the chat one more time. Let's see. Just looking to see one more question in the Q&A. Okay. Let me scoot down here. Yes. Oh, Sean has answered it, but just for the benefit of everybody, the question is, do all bands have 1 kilometer space resolution, or are there any with higher than 250 meter or 500 meter for coastal waters analysis? And Sean's response was the OCI instrument only provides data at 1 kilometer. All right, so let's see, anything else? You can find our webinar series on the NASA Earth Data NASA Earth Data YouTube channel. And I think we've probably got, I want to say there's like 300 and maybe even more than that at this point, 60 plus webinars. There are some specialized GIS playlists and probably about 4 dozen data discovery and data access tutorials. We mentioned the Earth Access Python library earlier, and a recent webinar, I think it was a couple of months ago, actually did have an extended section within the webinar where they were, going through a live demonstration for using Earth Access, and those same steps could certainly be applied once the PACE data is available. So I will put that link in the chat, and I also need to put the corrected OCB training link in the chat as well, which I'll do in just a moment. I'm going to give it one more chance, one more check for questions. I don't see anything additional in the Q&A. I will skip back up to the chat. I'm not seeing anything there. So at this point, what I would like to do is I'll leave the virtual meeting space open. I will insert those links in the chat. And I would like to thank all of you for joining us this afternoon, and thank our speaker, Alicia Scott, and thank our Q&A panelist, Sean Bailey, and my backup webinar host, Geraldine Tuart, for her assistance. And so with that, thank you all so very much. I'm trying to think in my head right now. The next webinar is coming up in April. The topic has not been identified, but we'll focus on land processes, data sets, services, and tools. All right, so you can look for that announcement on earthdata.nasa.gov. Thanks so much for joining us. And with that, I will say goodbye. All right, take care, everybody. We hope to see you at an upcoming webinar. All right, goodbye now.